Hi guys, I am Gustavo Chiara, Mechanical Electrical Engineering, and welcome to my channel. Today I'm going to talk to you about art ArcLink application. So it is that will apply all that we have learned in the 2 weeks before. Uh, it's its topic is about wells, digs, gears, and pulley. So let's go. Okay, the most important thing here is find the number of turns of the disc, well, etc. For example, in the picture you can see the initial point, the end point, and obviously the angle in a circular system. Well, in the picture you can see the letter N, which is the number of turns that a well makes when moving from A to B, or in that case from initial point to end point. So it's defined by the measure of the angle divided by 2p. This is the formula that we are going to use in order to get the solution of any problem. Well, in that case, for a well, so it means that, for example, it could be a car and it could be a truck. So in that case, we need to know which is the number of turns that the car makes, no, from moving to A and B. In that case, we need the length travel to the center of the well, and this number divided by 2p with r, that is the well radius, is the formula that you can find the number of turns in the case of the well. Well, in that case, we find a well on a flat surface. So in the picture, we can see the initial point, the end point. NB is the number of turns. The letter L is the length traveled through the center of the well, obviously, but in a flat surface. R is the well radius, and theta is the swept angle. So in that case, using the two formulas before, we defined that the number of turns in that case is equal to the length travel divided by 2p r. So and the number of turns is equal to the measure of the angle divided by 2p r. So as you can see, both formulas are equal. So we get another formula that is the formula that you can find the length arc. So this is the length is equal to the angle, the swept angle, multiply the radius. In your class you can find any kind of problem. For example, in the case that you have a vehicle, so in the picture you can see a vehicle that have two different wells. So in that case you can see that the radius of this well is much bigger than the other. So but remember that the vehicle, both wells obviously move the same distance, no? So in that case you can see that the number of turns that this well number 1 is equal to L, the length travel, divided by 2p r. On the other side, the number of turns of the well 2 is equal to the same length divided by 2p r. Obviously r is much bigger than the other r, minus r, and the number of turns in one is more than the other. So in that case we get this formula that we can relationship both wells. So in that case, the number of turns that the well number 1 multiply his radius is equal to the number of turns of the well 2 multiply the radius. So, but what happens in the case that you have a circular surface? Well, in a circular surface, you have a well up in the mountain and under the mountain. No, it's just a way to say. In that case, you can see the center of the well length move with a radius that is equal to the radius of the well plus the radius of the track in that case. So in this picture we define that the number of turns of the well is equal to the angle, the sweep angle theta multiply the radius of the track plus the radius of the well, obviously divided by 2πr. In the other case is the same situation, but the well is under the track. So in that case the formula is the same, but we need to minus both radius. It's very common find problems that have a disc or pulleys in contact or joined by a belt or chain. In both cases we need to know that the length of the disc in both cases is equal. So L1 is equal to the L2. So using the formulas before, we get that the sweep angle in the disc 1 multiply the radio 1 is equal to the sweep angle in the radio 2 multiply the radio 2. In the disc. This is in both cases, and is the same case that have a belt by in this way. Just remember that when a pulley have go to the left, the other one go to the right. And well, in that case, using the same formula, we get that the number of turns on the disc 1 is multiply the radius 1 is equal to the number of turns 2 multiply the radius of the 2. So remember that in a manufacturing, the number of turns is defined as a RPM, that in Spanish is revoluciones por minuto. So I don't remember how to say that in English, but is the number of turns is the number of turns that the disc do. Well, and the other case and the last one is that disc or pulley is concentric or joined by a shaft. In that case, remember in both cases that the sweep angle in both disc or pulleys is the same, and the length travel is, or the length of arc is different. So in both pictures we get that the sweep angle in both cases is equal. So using the formula before, we get that the length of arc 1 divided by the radius 1 is equal to the length 2 divided by the radius 2, and obviously the number of turns in both cases is equal. So it means that the RPM, revoluciones por minuto, are the same. Okay, this topic is very easy, and well, now we are going to resolve 4 problems. Problem number 1. If the well goes 1.75 turns from A and touching the vertical wall, what is the radius of the well? Consider the value of P, 22 divided by 7. So in that case, it's very useful drawing the picture in order to find the solution. So for example, the center of the well goes to the wall, and remember that the distance to the center of the well and the wall is the radius. And so in the picture we can see the distance traveled the well and the radius. So in that case, the formula that that use the length of the travel length and the radius is this. The number of turns is equal to the length divided by 2πr. So we need to replace the values. The number of turns 1.75 is equal to the length, that is equal, in the picture you can see 38 minus x divided by 2πx. So reducing the expression, we get that 11x is equal to 48 minus x. So reducing all the expression, we get that the value of the radio is 4. So in that case, for the problem 1, the answer is the letter D. Problem number 2. Determine the number of turns that goes the well to pass the obstacles if these are semicircles of the equal radius. So as you know, we need to draw in the picture all that you can read in the problem. So you can see that the well goes from this point to this one, and the radius go two distance, L1 and L2. So you need to write, and you need to get which is the swept angle that the well goes. So in this triangle we get this, that one side is r, the other side is 2r. So this is a remarkable triangle, and remember that the angle of this triangle, of this remarkable triangle, is 13 degrees. We are going to learn more about this in the following topics. So in that case, you can see a triangle. So we write a triangle, and we get a triangle equilatero in Spanish. So in this kind of triangle, we get that the measure of the angle is 60 degrees. In the same way, in this triangle that is equal to the first one, we get that the angle is equal to 30 degrees. Obviously, as you know, in this kind of problem, we need to get the value of the angle in a circular system. So in that case, we need to get the value of the angle θ1, and remember that in a triangle, in this case, the angles is equal to 180 degrees. So the measure of the angle of this swept angle is 90 degrees. In circular system is p divided by 2. In the same way, on the other side, we find a solution, we find a swept angle, and this is the same, p divided by 2. Well, we need to use in the formula that use the swept angle and the length. The swept angle and the radius. So in that case, the number of turns is equal to the angle, the swept angle, multiply the radius of the well plus the radius of the track, divided by 2πr of the well. So replace the values. We get that the number of turns is equal to 1. So in that case, for this problem, the solution is the letter D. Problem number 3. Find the integer of turns that the well of the figure going from A to B. So as you know, we need to draw. So the well move from A to B, and we need to draw in order to get which formula we need to use. So in that case, we know that the distance from A to M and the distance from M to B is equal to 6 and 8, and the radius is equal to 3 rays. So from A to B, using this formula, that the number of turns is equal to the length divided by 2πr, we get the number of turns that the well the number of turns that the well from A to M. So the number of turns is this value. So in the same way, from M to B, we get that the number of turns is this other value. Finally, from A to B, we need to plus both number of turns. So we get that the number of turns, and obviously replace the values, is equal to 1.287064. So in that case, the answer of the problem is the letter A. Problem number 4. In the system shown, if A goes n turns, the number of turns that go B and C add up to 15. Find the value of n. So in that case, we have two discs in concentric. So we know that the number of turns in both cases is equal. So using the date of the problem, we get that the number of turns B is equal to the number of turns of A. So is equal to n. In the other side, we get two discs connected by a belt, and so we get to use this formula that the number of turns multiplied the radius is equal to the number of turns multiplied the radius. So replace, we get this, the number of turns P, remember that is the value of n. So reducing the expression, we get that the number of turns or C is equal to 2 divided by 3, or 2/3 n. From the problem said that the number of turns of B and C add up 15. So replace the values, we get this, and reducing the expression, we get that the value of n is 9. So the answer of this problem is the letter D. Hi guys, that's all for today. Please remember, subscribe to the channel, share the video, recommend me with your friends, your family, because it's the way that you can help me. Always, I'm very happy to make these videos because it could be very useful for everybody, and it's the truth. Please remember and share the video. Thank you very much. Happy New Year. Bye.